Have you ever stared up at the stars and wondered what secrets the universe is hiding? Maybe you found yourself mesmerized by the endless night, your imagination drifting among the distant lights above. Beyond the moon, past the planets, and farther than the brightest stars you can spot, there's a universe so immense and ancient, it's almost beyond comprehension. To unlock these cosmic mysteries, humanity created something extraordinary, the James Webb Space Telescope, or JWST. It stands as the most advanced space observatory ever built. Picture it as our giant golden eye drifting in the cold void, a time traveler and cosmic investigator searching for answers about where we come from and what the universe is hiding. Unlike any telescope before it, JWST sees in infrared. This unique ability lets it look through thick clouds of dust and gas, exposing secrets that have been hidden for billions of years, like the universe's first stars and galaxies, and maybe even signs of life on far-off planets. Its enormous gold-plated mirror stretches over 21 feet wide, but to launch it, engineers had to fold it up like a piece of origami. Then, a million miles from home, it had to unfold perfectly, a daring feat that went off without a hitch. Now, JWST circles the sun at a spot called the second Lagrange point, far beyond the moon. From this remote outpost, it beams back images and data more breathtaking and profound than we ever dreamed possible. It's revealing a universe that's more vibrant, energetic, and surprising than we ever imagined, transforming our understanding of space itself. And just recently, JWST delivered something so shocking, so extraordinary, that it's forever changed how we see the cosmos, reminding us that the universe is full of wonders, just waiting to be found. How does JWST work its magic? It's all about light and time. When we look at distant stars and galaxies, we're literally looking back in time. Their light has traveled for years, even billions, to reach us. JWST is designed to see the oldest light in the universe stretched by cosmic expansion into infrared. Our eyes can't see this ancient light, but JWST was built to capture it. To do this, the telescope must stay incredibly cold, colder than anywhere on Earth, using a sunshield the size of a tennis court. Its gold-coated mirrors collect faint ancient light, while advanced instruments break it down into a spectrum, a cosmic fingerprint. By studying these fingerprints, scientists can learn what distant objects are made of, how hot they are, and how fast they're moving. This is how we uncover the universe's secrets. JWST is our ultimate time machine, revealing the story of the cosmos. And it's just getting started. The JWST's mission is grand. To look back over 13.5 billion years and witness the first stars and galaxies forming after the Big Bang. By seeing how the first galaxies were born and grew, we learn how our own Milky Way came to be. JWST also peers into stellar nurseries, clouds where new stars and planets are being born, giving us our first clear look at the creation of solar systems. It helps us understand how our own solar system, and Earth, might have formed. Another key goal: study exoplanets, planets outside our solar system. JWST can analyze the atmospheres of these worlds, searching for gases like water, methane, and oxygen, potential signs of life. Its mission: find the first light, watch galaxies assemble, see stars and planets born, and search for life's building blocks. Each discovery is a piece of the cosmic puzzle, and now, that puzzle has taken an extraordinary turn. For months, the James Webb Space Telescope, or JWST, delivered spectacular images of the cosmos, dazzling nebulae, ancient galaxies, and the birthplaces of stars. But for a select group of scientists, these breathtaking visuals were just the beginning. They were searching for something far more profound, a sign of life beyond Earth, a signal that we are not alone in the universe. Dr. Eris Thorne's team set their sights on Kepler 186f, a rocky exoplanet orbiting within the habitable zone of its cool, red dwarf star. This is the region where conditions might allow liquid water to exist, a crucial ingredient for life as we know it. Although Kepler 186f is an astonishing 500 light-years away, JWST's powerful instruments can study its atmosphere from our distant vantage point, peering across the vast gulf of space. The team waited patiently for the rare moment when the planet would pass in front of its star, a transit event. During these transits, JWST could capture the faint starlight that filters through the exoplanet's atmosphere, revealing its secrets. At first, the data was frustratingly noisy, like trying to hear a faint whisper in a crowded, bustling room. Every signal was buried beneath layers of cosmic interference and instrumental noise. Undeterred, the scientists worked tirelessly, collecting more and more data with each transit. By stacking and analyzing the results, they gradually built a clearer, more detailed picture of Kepler, 186F's atmosphere. Then, after the fourth transit, something remarkable happened. A distinct pattern began to emerge, a chemical signature in the light spectrum that was unlike anything the team had ever seen before. It was a combination of gases so rare, so unexpected that it seemed almost impossible. The ratios didn't match any known geological or chemical processes. On Earth, this exact signature is produced almost exclusively by living organisms. It's a fingerprint of life, a clue that biology might be at work on this distant world. The faint whisper from 500 light-years away was growing louder, transforming into a shout that demanded attention. The team realized, with a mix of disbelief and exhilaration, that they might be standing on the threshold of the greatest discovery in human history, the detection of life beyond Earth. The data was now clear and undeniable, but the implications were staggering, sending ripples of excitement and awe through the scientific community. Humanity was about to learn something extraordinary, something that could change our understanding of life, the universe, and our place within it forever. The control room was electric, buzzing with anticipation, and a sense that something extraordinary was about to happen. Scientists huddled around a glowing screen, their faces illuminated by the final data streaming in from Kepler, 186F, a planet hundreds of light-years away. Graduate student Lena, hands trembling with excitement, initiated the last crucial analysis that would determine the fate of years of research. The room fell silent, every breath held, as the progress bar inched forward on the main display, each second stretching into eternity. Suddenly, the graph snapped into focus. Distinct peaks appeared, indicating the presence of nitrogen, carbon dioxide, and, most remarkably, a strong, unmistakable signal for water vapor, the essential ingredient for life as we know it. But then, two new peaks emerged side by side, more pronounced than anything they'd seen before. Methane and oxygen, both present in significant amounts, their spectral signatures clear and undeniable. On their own, either gas could be explained by geological processes, like volcanic activity or chemical reactions in the crust. But together, in that precise ratio, it was unprecedented. No known natural process could account for it. Dr. Thorne, the mission's lead scientist, immediately asked for every possible non-biological explanation to be checked and rechecked. Lena had already run them all, every geological and chemical model they had. Nothing fit the data. No known process could produce this much oxygen and methane together, except for one: widespread active biology on a planetary scale. The only model that matched the evidence was one with global photosynthesis, a living world breathing beneath alien skies. The room was silent, not with disbelief but with awe, as the magnitude of the discovery settled in. They had found the strongest evidence yet for life beyond Earth, a moment that would change humanity's place in the cosmos forever. The universe had just revealed a new secret, one that would echo through history and inspire generations to come. The search for life was no longer just a dream or a distant hope, it was now a reality unfolding before their eyes. Humanity had crossed a threshold, stepping into a new era where we were no longer alone in the universe. The cosmos would never look the same, and neither would we. So what did JWST discover? Not aliens, but something even more profound. A biosignature in Kepler 186F's atmosphere. A biosignature is a chemical fingerprint, a combination of gases so unlikely to occur naturally that it points to life. On Earth, oxygen and methane together means something is constantly replenishing both, usually life. JWST found both gases in abundance, along with water vapor and a rocky surface. The planet is in the habitable zone with signs of oceans or a humid atmosphere. Scientists have tried every alternative explanation, volcanoes, strange chemistry, but nothing fits. While not absolute proof, this is the strongest evidence for life beyond Earth we've ever seen. The signal is clear and the implications are enormous. The universe just got a lot more interesting. The search for life has a new champion. Finding a potential sign of life 500 light-years away changes everything. For centuries we've wondered if we're alone. Now science has brought the question into reality. This discovery suggests life might not be unique to Earth. If the right conditions exist, life could be common. It's a fundamental shift in our understanding of biology, chemistry, and our place in the cosmos. It inspires new questions. What kind of life could thrive on Kepler 186F? How does photosynthesis work under a red sun? It also reminds us how precious our own planet is and why we must protect it. The discovery will fuel dreams of exploration, pushing us to build better telescopes and reach further. The universe is full of wonders waiting to be found. We are explorers at heart, and the journey just got more exciting. The stars are calling, and we're ready to answer. The discovery on Kepler 186f isn't an ending, it's a beginning. Scientists will now study this world and others, searching for more signs of life. JWST will keep exploring, mapping clouds, seasons and temperatures on distant planets. Is Kepler 186f unique, or the first of many living worlds? The hunt is on. Science is about curiosity and courage, asking big questions and daring to find answers. The universe is dynamic, full of surprises, and we're just starting to listen. Our golden eye in space has opened a new chapter in our story. The journey into the cosmos has just begun. Let's keep exploring.